On behalf of 24HourAnswers.com, I welcome you to today's lesson. Alright, in this video, we're going to look at an example of related rates that deals with the area of a circle. And a common problem that I see in calculus textbooks deals with like a water puddle. You're pouring some water out and it spreads out as a circle onto some surface. The radius of a circle is increasing at a rate of 5 inches per second. At what rate is the area of the circle increasing when the radius is 30 inches? Round your answer to the nearest square inch. Since we're talking about a circle and we have area, we do have a formula that's very common. The area of a circle is pi r squared. Now, what are some things that we have and what are some things that we're looking for? The radius is increasing at a rate of 5 inches per second. We refer to this as dr dt, and that's going to be 5 inches per second. This is the rate of change of the radius with respect to time. When we go and apply some implicit differentiation right here in a moment, we will use this 5 inches per second for dr dt. We are trying to find the rate of change of the area, so we're trying to find dA dt. That's what we're trying to address here. What is the rate of change of area with respect to time when the radius is 30 inches? Now we'll come back and talk about the 30 inches in a second. Let's take the formula for the area of a circle and let's differentiate all of our variables with respect to time. The derivative of A is going to be 1 dA dt, so we can just write dA dt is equal to the derivative of pi r squared with respect to time. Let's differentiate the r squared, so we have 2, I'm going to bring my pi down, r to the first, and since we're differentiating with respect to time, we tack on the dr dt. All of your related rates problems, whatever variable you differentiate, make sure you tack on a dA dt or a dr dt or d something dt based on whatever variable you're differentiating. Well, look at what we have here. We have dA dt, which is what we're trying to find, is equal to 2 pi. We have a specific radius we're talking about, 30 inches. So we have 30 inches. dr dt is 5 inches per second. So dr dt, let's plug in that 5 inches per second. And I'm using my units here too for a reason. You'll see why we are left with a rate of change of area once we multiply this stuff out. So therefore we have dA dt, the rate of change of area with respect to time when our radius is 30 inches is 30 times 5 times 2, that's going to be 300, bring down your pi, square inches. Now notice what I have there. I'm taking inches times inches, therefore we have square inches per second. And if you look at your units here, square inches, since we had inches times inches, per second, this is a rate of change of area. Square inches per second is our dA dt. And let's go ahead and round this off to the nearest square inch. So taking 300 times pi, we have around 942 square inches per second. And there you have it, an example of related rates that deals with the area of a circle. And again, a very common problem you will run across is a water puddle where water is dripping onto a surface or flowing onto a surface, and that water is forming a circle on that surface. And very often you will be asked to find the rate of change of the area, or sometimes you may be asked to find the rate of change of the radius. We'll look at another example with the area of a circle where maybe we're looking for another rate instead of area like we did here. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.